Okay, now consider the case 1, the simplest case. What if k equal to 0? Then we have quite a simple expression, and the simple expression is r square r double dash r square double derivative r plus r into r dash equal to 0. What about theta? Theta double dash equal to 0. You just write k equal to 0 and you just write k equal to 0. Okay. How to solve it? Well, see, double derivative of theta equal to 0. What does that mean? That means if you need to double integrate it. Now theta is a function of smaller theta. So if you integrate it once, you get a constant, let's say c1. Now if you integrate it again, then if you integrate a constant and you get theta plus another constant c2. What about here? Here we can write let we need to write let r dash equal, okay, let's write r dash equal to s, just to make it simpler in look. Then we will have r square s dash plus r into s equal to 0. Now you generally don't have that r is 0, that will just reduce your point to a point, so we neglect the case r equal to 0, and so we have r into s dash plus s equal to 0. Now that's a first order differential equation. We have the standard form. So your integrating factor here is e to the power integral of 1 by r dr. That's just r. And if you multiply by r, you have r into s dash plus s into 1 equal to 0. If you multiply by r, you have r into s dash plus s into 1 equal to 0. That is nothing but ddr of s into r equal to 0. That implies s into r equal to, say, constant. You got c1 and c2. Let's write c3. Now s is again derivative r. So here you have, let's go to the next page. We have, let's write in the next page first of all. We got s into r equal to c3. Did I copy correctly? S into r equal to c3, yes. And your s is derivative of r with respect to r. You can take, and so you just need to integrate it. Therefore, what is u? U is a function of r comma theta, and that is r, that is a function of r, into theta, that is a function of theta. So that's equal to C3 log r into whatever theta. Theta was, capital theta was C1 into smaller theta plus C2. Bingo, that's the general solution when your k equal to 0. But k need not be 0. So let's look at the other case when k is not equal to 0. Okay, what if k is not 0? If it is not 0, then either it is greater than 0 or less than 0. So let's consider the case 2. Case 2 I have already written, so I don't have to write case 2 again. Case 2, let us consider the case k is greater than 0. Okay, if it is greater than 0, then we can always write k equal to p squared, where if it is positive, then it must be a square of another number. Therefore, what are the two equations we have? If we have case k to be positive, then we can write, let's say, equation. So far we haven't used any equation. Therefore, equation 1 and 2 can be written as equation 1 is r square r double dash plus r dash minus kr equal to 0. So you'll have r square r double dash minus r dash, did I copy correctly, plus r dash minus kr equal to 0. Minus kr, k is p square, and double derivative of theta, what is the expression here, plus k theta equal to 0, and k is p square, plus p square theta equal to 0. Then, what to do now? We need to solve it. Okay, we can solve it if we can solve this. These are homogeneous differential equation of order 2. This one, it's pretty simple. If you remember, it's just a simple harmonic motion kind of problem. You might be able to solve it directly, or you may note the direct answer for that. But for this one, this is homogeneous differential equation of order 2. Let r equal to e to the power z Then by theory of homogeneous differential equation of order 2, you will have d dr can be written as r ddr can be written as t dz, and r square ddr square d2dr square can be written as d square dz square minus d dz. And okay, this one you can solve it. You'll have complementary function. This one, let's write it as d square plus p square theta equal to 0, where we can d is d theta. I can approximately write it that way. That's how we solve differential equation of order 2. Okay, so this one we have it here, this one we have it here. So d2 dz square of r minus d dz of r plus d dz, oh lucky guy, minus p square r equal to 0. You can cancel this. If we cancel it, then we have quite a simple expression. What do we have? d2r dz square minus p square r equal to 0. And here you will have the other portion. You will have complementary function to be cf is your c1 cos p theta. Oh, we already have c1, c2, c3, so let's write c4 cos p theta plus c5 sin p theta. What about here? Here we have complementary function is given by r equal to we already have c4, c5. Let's write c6 e to the power pz plus c7 e to the power minus pz. And so r equal to your c6 e to the power z is just r, so r to the power e to the power z is r, so that to the power p plus c7 r to the power minus p. And what about the other side? Other side we have theta equal to c4 cos p theta plus c5 sin p theta. Is your right hand side is 0, as your right hand side is 0, you don't have to compute particular integral. The same is true here. And so we can write u r comma theta s r, that's a function of r, into theta, that's a function of theta. c6 r to the power p plus c7 r to the power minus p, and c4 cos p theta plus c5 sin p theta. Now that's the case 2 when we assume k is greater than 0. What about case 3? First case we took k equal to 0. First case we took k equal to 0, where yes, case 1 k equal to 0, we have it. Second case we took k greater than 0. Then we have another solution. At last, let's take case 3. We have case 2 k greater than 0, and we have at last case 3 k less than 0, let k equal to minus p square. Okay, then what about your differential equation? How will it look like? So equation 1 and 2 can be written as r square r double dash plus r dash plus p square r equal to 0, and theta double dash minus p square theta equal to 0. Once again, you will choose let r equal to e to the power minus z, then r d dz is equivalent to d dz, and r square d2 dr square is equivalent to d2 dz square minus d dz. So your equation will reduce to d2 dz square of r minus d dz of r plus d dz of r plus p square r equal to 0. Again, d dz of r gets cancelled, and so you have d2 r dz square plus p square r equal to 0, and in that case your solution is r equal to c, what was the c that we used last time? We have used c6, c7, let's write c8 cos pz plus c9 sin pz, and your r is e to the power z, so z has to be equal to log r, so that is c8 cos p log r plus c9 sin p times log r. What about theta? Well, here you have complementary function is your theta equal to d square minus p square equal to 0, so d equal to plus minus p, so you have C10 e to the power p theta plus C11 e to the power minus p theta. If we combine these two, we'll have u r comma theta, that's a product of r into theta equal to C8 cos p log r C9 sin p log r. It's better to keep it in bracket. Whole thing into C10 e to the power p theta plus C11 e to the power minus p theta.